Hi folks, welcome back to another lesson, and we're going to start a new topic which is all about pressure and gases. So the first lesson, a nice straightforward, and I would hope you find this fairly straightforward, is something called pressure. And we're going to define what pressure is, calculate the pressure for different situations, and solve everyday problems involving pressure. So first of all, and this is quite relevant I suppose to you because we see a lot of these around town or outside town, why do tractors have big wheels, right? Why do they have big wheels? Now, you might be able to tell me one reason why is because it stops it from sinking into the mud, and you'd be very correct about that. But then the question is, what is the physics behind how that works? Why is it that bigger wheels will stop you from sinking into the mud? So let's hopefully look at this in a bit more detail and you'll be able to answer this by the end of the lesson. So let's get straight into it. Pressure is defined as the force per unit area. So I would like you to copy the slide because this is your notes. And the equation is pressure is equal to F over A. So you can find it in your relationship sheet so you know where it is. The units for pressure is that it's pascals, named after the French gentleman who did a lot of work on this, and it's usually written as capital P little a. Forces, which is in newtons, area, which is in meters squared, and remember it's ms with no minuses there. And a wee bit that's also important for you to know is that atmospheric pressure is always 1.01 times 10 to the 5 pascals, and you might find this useful for when you come to do some of the questions in the tutorial. So in case you're wondering, because I know some of you really like using this, but the equation triangle is the following. It's pressure along the bottom, force at the top, and then you have area underneath there. Okay, and hopefully you know how to use the triangle, but the area is given by the force over pressure, so F over P, and the force is given by pressure times area. So if you're not confident about rearranging the equation, I would copy down the triangle and also the equations there as well. So let's look at doing some of these calculations now. One of the trickiest part about calculating pressure is working out the area. So there's two ways to do it. One is we can do it by converting the area straight from centimeters to meters squared. So to do that, you would change by dividing 10,000. So I'm going to show you how to do that. So if you can write this down, folks, because that's how you convert from centimeter squared to meter squared. So let's look at the example. We've got a shape with I'm just going to call this the length of 70 centimeters and a breadth of 10 centimeters. So we've got that there. And you probably know that to get the area, you do length times breadth. So it's 10 times 70, which is 700. And then remember, this will be in centimeters squared. So to convert it into meters squared, we simply divide by 10,000. So that's what I mean by change by divide by 10,000. So that's one way to convert centimeters squared into meters squared. So the other way to do the conversion is to do converting lengths from centimeters into meters and then work out the area. So again, if you make a wee note of that so you know the second way of doing it, and also make a note that to convert centimeters to meters, we divide by 100. But I would hope you all know that by now. So how do we do this? Let me show you. We have the length, which is 10 centimeters. So divide by 100 gives us 0.1 meters. We have breadth as 70 centimeters, so divide by 100, we have 0.7 meters. And because they're already in meters, we can just use these answers to give us the area, which is the same as before, because it's the same shape. Now it's up to you which one you want to use. I'm not fussy as long as you know how to use the one you've chosen and you always get it correct. So let's get on to doing some pressure calculations then. So a Yeti has a mass of 245 kilograms. Each Yeti feet has a surface area of 0.85 meters squared. Calculate the pressure the Yeti exerts on the ground. So, first of all, if you are confident in how to do this, try it yourself. I'm going to show you the answer in the next couple of slides. So pause the video, try it yourself, but let's show you how to do it. So, as always, and I hope by now you're really sick and tired of me saying this because it's burned into your brain, KFC technique. So know it. So first of all, we know there's a mass of 245 kilograms, and the pressure, we have to be very careful because it says each Yeti feet has a surface area of 0.85 meters squared. And we're assuming the Yeti has 2 feet, so that's why we have to double this to give us the area of 1.7 meter squared. And this bit here is the bit that usually catches people out. So now that you've seen it, I'm hoping you'll be watching out for it. Once we know it, we find our equation, which is simply pressure is equal to force over area. We then calculate it, so we plug in our numbers and we get our answer. Now here the answer is 1.144.11, so we round it to the nearest whole number and we get 144 pascals. And that's how you do this calculation. But again, notice there's a routine there, KFC. Know it, find it, calculate it. The only trick here that you really have to remember is this doubling the area because it's 2 feet rather than 1. Okay, another example. Again, feel free to try this example yourself. So a box sitting on a table has length 20 centimeters, breadth 15 centimeters, and a height 10 centimeters. A mass of 1.5 kilograms, fits perfectly in the box. What pressure does the box exert on the table? So pause video and try it. Okay, hopefully again you know straight away we're using our KFC technique. So remember, we have the mass, which is 1.5 kilograms. The area is 20 times 15. Now I've kept this in centimeters, so I need to divide by 10,000 to give me this as the area. Now, did you notice the wee trick that we're given the height, but remember, if the box is sitting on the table, the height doesn't matter. It doesn't contribute to the area, so this is actually a bit of a red herring to try and catch you out. Once you've got that, you can hopefully see the next stage is just find it, P is for F or A, calculate it, then we get our answer, which is exactly 50 pascals. So again, there's the same routine of know it, find it, calculate it. Again, there's a wee trick with the area. In this case, you had to realise it was just 20 times 15 and you had to convert it into meters squared. Now, a final question, and this is an open-ended question, we haven't done much of these, but given the following objects, which will sink into the snow quickest? Use your knowledge of physics to explain your choice. So we've got a football boots with some studs in it, and we've got something which looks like a tennis racket, but it's actually a snowshoe. So pause the video, think about which one would sink the quickest, and see if you can explain why. I'll give you the answer in the next slide. So hopefully you said that the football boots would sink the quickest, and the reason is for the following. Football boots sinks the snow the quickest, and this is because pressure is equal to force over area. So this tells us a smaller area means a bigger pressure, since dividing by a smaller area means P will be bigger. Now if you don't believe me, you can make up some numbers and try it. So let's just assume, say for example, the force is 100 newtons. Okay, and what you can do is you could try, say, an area of 50. Okay, make these numbers easy for you to divide because we're just trying to show something here. Or you can make the area 2, and you should find with the area 2, which is smaller than 50, you get a much bigger pressure. So to finish off our answer, and we want to link it into the question, since the studs on the football boots have a smaller area than the snowshoes, the football boots will sink into the mud, or the snow in this case. And this is how we use the physics to explain that question. Ironically, we do want studs in football boots because if you're a footballer and you're running on grass, you don't want to slip on the grass, so the studs will actually dig into the grass much more easily, and that means you'll have a better grip.